Permutations continued. When repetitions are allowed, for calculating the number of ways in which the arrangements can be made, when repetitions are allowed, we use the formula n power r. The other formula we see here is n factorial by n minus r factorial. That is the formula when repetitions are not allowed. And it is the general formula for NPR. This formula was mentioned in the first session of permutations. Let's look at an example problem when repetitions are allowed. Let me read out the problem statement to you. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 and 6 when repetition is allowed. Let's look at the solution. The number of 4-digit numbers which can be formed using 6 digits 1, 2, 3, 4, 5 and 6 is calculated by using the formula n power r, where n is the number of digits given and r is the number of digits taken at a time. So the number of digits given in the set are 6, and we have to form 4-digit numbers. So we should take 4 digits at a time from the set. So n is equal to 6 and r is equal to 4. After substitution and calculation, we get the value as 1296. The total number of 4-digit numbers which are formed are 1296. Now let's look at the number of 4-digit numbers formed visually. Draw 4 blanks 1, 2, 3, 4, and in the first blank the number of options are 6. 1, 2, 3, 4, 5 and 6 are the digits. So totally the number of options are 6. In the second blank also, the total digits allowed are 6. So the number of options are 6. And in the third, fourth also, the total number of digits allowed are 6 and 6. So therefore, by counting principle, the total number of 4-digit numbers obtained when repetition is allowed are 6 into 6 into 6 into 6, that is equal to 1296. Now the next topic is circular permutations, which is very important. Now let's look at linear permutations with an example. In the next slide, I will explain how to write circular permutations for the same problem. Let me read out the problem statement to you. Write the number of linear permutations of 1, 2, 3, 4 taken 3 at a time. That is the problem statement. So first, take the digits 1, 2, 3. So this is the set. You can arrange the digits 1, 2, 3 internally among themselves in 3 factorial ways, and the value is 6. Now next, let's go for 2, 3, 4. For the set 2, 3, 4, when you make the internal arrangements, we get 3 factorial number of permutations, and the value is 6 again. Now the next set is 3, 4, 1, and this is the set. Again the internal arrangements are 6, and for 4, 1, 2, the internal arrangements are 6 again. The total number of linear permutations we get are 6 plus 6 plus 6 plus 6, that is 24. Okay. I have written in detail the whole set of linear permutations to you so that it is easy to convert them into circular permutations, and that is explained graphically in the next slide. Now let's look at the circular permutations of the same problem. The first set of linear permutation is written in this circle. The second set is written in this circle, and the third and the fourth is written in these circles. So the first linear permutation is 1, 2, 3, 1, 3, 2, and so on. And there are 6 of them. To count the number of circular permutations, first we write the number of linear permutations and then count the main set as the single circular permutation. So 1, 3, 2 or 1, 2, 3. Here it is considered in the anti-clockwise. And 1, 2, 3 is one circular permutation. Now let's look at the second one. For this, for the second to count the second circular permutation, let's write the second line of linear permutation which we have written in the previous slide inside this as a set. Two, three, 4 is the main set, and these are the 6 linear permutations. The main set 2, 3, 4 is considered in the anti-clockwise direction as one circular permutation. Okay, so this is number 2. Similarly, this is number 3 and this is number 4. So, just counting the number of permutations in the anti-clockwise direction, we get totally 4 of them. Considering the clockwise direction, we get another 4 of them, and totally there are 8 in number. Let's look at the same problem using formula in the next slide. Let's count the number of circular permutations for the same set using the formula. This is the given set, and we are asked to calculate the number of circular permutations taken 3 at a time. The total number of digits n is equal to 4. This is the total number of digits in the given set. And from this, we are asked to take 3 at a time. So R is equal to 3. So for calculating the circular permutations, considering both clockwise and anti-clockwise, the formula is NPR divided by R. So that is 4p3 divided by 3. 4p3 is 24 by 3 gives you the answer 8. So this is the number of circular permutations we get considering both clockwise and anti-clockwise. More videos coming up from Math Motive. Please like, share and subscribe. Bye. Thank you.